Along the Huangpu River, shipbuilding docks are being quietly reinforced, while in Bohai Bay, gantry crane tracks have been extended to 200 meters. China's shipbuilding industry is laying the groundwork for a new generation of maritime powerhouses. A U.S. Congressional report released this August revealed that the U.S. Navy has accelerated the construction timeline for its next-generation DDGX large destroyer. The launch date for the lead ship has been moved up from 2034 to 2032, and the completion date from 2039 to 2037, a full 2-year advance. This sudden acceleration of a project viewed by the U.S. as the future backbone of its naval technology signals Washington's full-throttle push in the competition for naval surface dominance. The primary reason for this urgency among the world's superpower is China's combat-ready Type 055 large destroyers. All 8 vessels of the first batch of Type 055 destroyers have been delivered to the Navy, while the 6 ships of the second batch are under orderly construction. These warships have been designated as the 109 Dongguan, 110 Anqing, 111 Zhuhai, 112 Harbin, 113 Qingdao, and 114 Fushun. Both the Dongguan and Anqing have already been launched, with all 6 second-batch 055 destroyers expected to be delivered to the Navy by the second half of 2027. The Type 055 truly pioneered a new era in naval development, with navies worldwide benchmarking its design philosophy to produce a wave of next-generation guided missile destroyers, truly the dreadnoughts of the modern age. However, construction of the lead Type 055 began in 2017, meaning 8 years have passed since its inception. The 055, once a pioneer in future technological standards, now lags behind the US DDGX destroyer in technical specifications, revealing certain shortcomings and flaws. In terms of displacement, the US DDGX destroyer boasts a displacement of 14,000 tons, while the 055 large destroyer only reaches 12,000 tons, already surpassed in hull platform space and redundancy. Japan's Maritime Self-Defense Force plans to build 18,000-ton large destroyers, surpassing the Type 055 by 6,000 tons in displacement. The displacement of active frigates in major navies worldwide has generally reached over 7,500 tons, with future large destroyers commonly planned for over 10,000 tons. The Type 055's 12,000-ton displacement is not particularly large by these standards. The U.S. DDGX embodies the electric warship concept. It employs a configuration of 4 LM2500 GE4 gas turbines paired with 3 EG 9160 or F diesel generators, utilizing an all-electric propulsion system integrated with a comprehensive shipboard power management system. This design enables the DDGX to deliver at least double the shipwide electrical power output of the Arleigh Burke destroyer while maintaining equivalent propulsion capabilities. The DDGX can generate a total electrical output of 156 MW. After accounting for propulsion system requirements, it still has at least twice the available electrical power of the Arleigh Burke to drive radars and electronic equipment. The Type 055 large destroyer does not employ electric propulsion technology. The power generated by its 4 GT 25,000 gas turbines is entirely used for propulsion. Radar and electronic systems rely on dedicated generators, which meet basic requirements but limit performance upgrades. The Type 055's radar and electronic equipment power levels are comparable to the Arleigh Burke III, but it carries only 2 sets of high-power electronic countermeasure systems, 3 fewer than the DDGX. In terms of weaponry, the DDGX is equipped with a 96-cell vertical launch system, 12 cells of which can launch ERC's hypersonic missiles, giving it firepower comparable to the Type 055. The DDGX can also launch anti-ballistic missile interceptors, granting it superior sea-based mid-course missile defense capabilities over the Type 055. Regarding production volume, the first 2 batches of Type 055 large destroyers total 14 vessels. The U.S. has included 28 DDGX destroyers in its 30-year shipbuilding plan, reaching twice the scale of the Type 055 fleet. The total investment in R&D and manufacturing amounts to $100 billion. The first 2 batches of Type 055 destroyers have already become technologically conservative and outdated, necessitating urgent changes and countermeasures. Development of the Type 055B large destroyer has been prioritized. Ship engineering papers reveal that China's new destroyer design features a full length of 195 meters and a full load displacement approaching 17,000 tons, significantly exceeding the 13,000-ton displacement of the current Type 055. The domestically produced CGT-30M gas turbine engine delivers 33.5 megawatts per unit, representing a 25% increase over the engines currently installed on the Type 055. 4 CGT-30M engines deliver a combined output of 134 megawatts, with over 20 megawatts of surplus power available outside the propulsion system, perfectly matching the energy requirements of a 40 megajoule electromagnetic railgun. Medium voltage direct current integrated grid technology enables flexible power distribution, supporting the installation of high-energy consumption equipment like laser weapons. The 055B's length may slightly increase to 183 meters while maintaining a beam of 21 meters. With displacement controlled around 14,000 tons, vertical launch cells could expand to 128 units, continuing the proven 055 configuration to ensure rapid mass production. Its core advantage lies in compatibility with existing systems, allowing reuse of 055 maintenance facilities and tactical procedures. A more radical proposal, codenamed Project 58, features an exceptionally wide 25-meter hull with a length-to-width ratio reduced to 8.12. This design enables dual hangars and 144 VLS cells, but requires rebuilding production lines and support systems. A 17,000-ton hull could theoretically accommodate 144 VLS cells, but naval technical experts caution that excessive compression of living quarters would degrade crew combat readiness. The 128-cell variant ensures 6 square meters per crew member, meeting the stringent requirements of the updated ship compartment design specifications. The next-generation VLS system will retain its 850 mm diameter advantage, enabling deployment of the YJ-21 hypersonic missile, range 1,500 km, terminal velocity, Mach 10. Its firepower surpasses the Type 055 by 40%, with a single salvo capable of intercepting 12 aerial targets, far exceeding current operational vessels. With displacement increased to 17,000 tons, fuel capacity rises by 40%, extending endurance from 28 to 45 days. This class can independently conduct distant maritime control, expanding patrol radius by 70 nautical miles, beyond the Type 055 to serve as a maritime pivot for the Belt and Road Initiative, serving as the armed escort for domestically built carriers like the Fujian. These new vessels can establish a 1,500-kilometer anti-access fire zone through enhanced radar and electronic warfare capabilities. In West Pacific confrontations, a single Type 055 once forced a U.S. two-ship formation to retreat. The new generation will project even greater deterrence. Japan is not to be outdone, having publicly unveiled its Asive destroyer model and announcing plans to build 2 new destroyers, with a displacement of 16,000 tons and equipped with 128 vertical launch cells. Unlike Japan, whose core components rely on the United States, China's CGT-30M gas turbine engines, dual-band radars, and integrated power systems are now 100% domestically produced. While Japan pays exorbitant prices for American equipment, Chinese shipyards are significantly shortening construction cycles using modular power packages. The roar of machinery never ceases within China's shipyards. On the slipways of Jiangnan Shipyard and Dalian Heavy Industries, the contours of the next generation of maritime dominators are gradually taking shape. The U.S. DDGX program's 2-year acceleration clearly signals an intensifying naval arms race. The 055B must urgently integrate full ship power management systems and adopt naval power energy solutions developed by academician Ma Weiming and other research institutes. Concurrently, its anti-missile intercept capabilities must be enhanced to counter the URC's hypersonic missiles, now being deployed by the U.S. Navy. The future 055B large destroyer must evolve into a formidable warship, approaching 14,000 tons displacement, featuring full ship electric propulsion and integrated power management, and equipped with enhanced electronic countermeasure systems and anti-missile interception capabilities to sustain its competition with the DDGX. This time, the U.S. is not only genuinely concerned, but also taking decisive action. They plan to build technologically superior new warships to counter the 055, while also deploying a larger fleet than China's 055 class. Only such a U.S. deserves its status as the world's superpower and stands as a formidable rival to China's defense industry. Naval competition is an endless marathon. China has transitioned from follower to frontrunner and must now accelerate its pace.